Graphite has an integrated audio mixing engine called RAVE. RAVE is built into the same hardware subsystem as the Graphite video processing engine and runs on the PCI card. With our RAVE system, we can access it directly inside of Dashboard. The audio mixer consists of multiple stereo channels as well as mono channel inputs. There are 4 mixes out of the system. There's a main mix, an aux1, aux2, aux3. Your outputs, you have the ability to configure 4 stereo audio mixes and 1 monitor output as well. The mixer consists of all 12 SDI inputs are then internally fed into the audio mix engine. In addition, all 4 expression frame buffers, so your clip channels as well as your graphics channels, also come into the audio mixer as independent stereo audio feeds. The media store channels have, for Media 1 and Media 2, stereo audio embedders as well. What happens here is that the media store will play out that WAVE audio file that has been associated with the graphic, and it will be played into the audio mixers. The PC audio is also built into the Graphite driver that is inside of the Windows platform. So on the Windows platform, the RAVE audio mixer has both a stereo pair input as well as a stereo pair output. Leaves the PCI card across the PCI Express bus and goes back up into the Windows environment to be accessed by applications, as well as the sound mixer to be sent directly out and output. The AES and the 8 analog inputs, these are all coming off of the RAVE audio breakout unit. Now the RAVE audio breakout unit will embed these channels into input 12's mix. In group 1, channels 1 and 2 of the embedded audio, we're passing through the SDI source's audio. And the remainder 4 channels in each of group 2, group 3, and group 4 are now available for us to embed these additional audio channels to then bring them into the overall RAVE audio engine. So inside of the RAVE audio engine, we now break these down, and this allows us added audio channels for our mixer. So the AES connector that comes into the system is a stereo pair and can be controlled. The analog inputs come in and are mono channels. So with the mono channels, you now have the flexibility of panning them instead. So the analog inputs come into the system embedded into that 12th input. If you have the 8 input or the 4 input SDI systems, you'll still connect the audio breakout unit directly to the physical input 12 and directly to the output 4. However, you don't need to worry about connecting a video path in that case. Also, if I'm doing a production where there is no 12th input, nothing needs to be connected to the audio breakout unit video-wise to send down to the 12th input. Each of the auxiliaries, 1 through 3, also have their own independent outputs. So these are full stereo mixers that you can use for auxiliary mixes. On the config tab, we have the ability to name, independent of the system, the names that we'd like for those inputs. So these can get the same name as the actual input, or this allows the audio operator to reconfigure them for names that make more sense to them. Next up, you've got your ordering. So each mixer can have its own custom layout. So each channel can be moved around in the mix so that they can be lined up how they're best suited for that individual mix. You can make them visible or not visible. So channels that I may not need to see or to control, I can simply uncheck those channels and not have to worry about including them inside of the mix. aux1, aux2, and aux3, again, also have their ability to be independent for their configuration and their layout. Once you've made a change, When you go back to that mix, you'll notice in the middle you have the ability to view just your custom layout. So now the reduced I/O and the reshuffling of how I wanted them configured, as well as you can at any time go to all channels so that you can break out and see every single one of the faders and channels that's available. Now, from our output configuration tutorial, we covered how to assign the audio mixer outputs to the destinations. But real quickly, we'll just jump into it again. So when we go to the configuration menu, this is where on the output tab, we define what each output is going to get. So the video paths that go into the clip store, so being able to record video or use that video live inputs inside of the expression graphics system, those have the ability to select either pass-through to take the audio from the video that's going up to it, all mixes, so embedding them in the exact order that you see here, where main would be on 1 and 2, aux 1 would be on 3 and 4, aux 2 on 5 and 6, aux 3 on 7 and 8, and finally the monitor would show up on channels 9 and 10. Your physical outputs 1 through 6 can also be assigned. Notice that HDMI does not have audio output. Now, output 4 cannot be assigned because it must always have all mixes sent to it, because that is the connection that we connect into the audio breakout unit. And that needs to provide all of the mixes so that anything can be selected on any of the analog or AES outputs. Your other outputs can again select anything that you want. So we will embed into the SDI stream either all mixes or a specific one of the 3 aux mixes, or even the monitor output. So here, because my output 5 is using the multi-viewer, I could select the monitor so that the audio channels that will go up to my multi-viewer will be coming from the monitor feed output as opposed to the program feed. When it comes to the audio breakout units, that's the rightmost column. So on the RAVE audio breakout unit, there are 5 analog outputs. Each analog output can either select from the left channel, the right channel, or a mono sum of any of the mains, the auxes, or the monitor output. Because AES is a stereo pair, the AES allows you to just pick main, aux 1, aux 2, or aux 3. On our PC audio, this is what is feeding that RAVE audio driver. So the Graphite driver that knows everything about the PCI Express video card also has an audio driver. That audio driver allows me to send those 2 channels down that show up in the mixer, but also allows me to take any of the 4 mixes or the monitor output and bring that back into the PC environment for access either from applications or to use it directly on the I/O that the PC audio card gives us. So that's your audio path in and out of the audio mixer. Now when we look at what we have for controls, all of our video channels, so all SDI inputs, all of the expression frame buffers, so our graphics and our clips, and our media stores have the ability to have audio follow video. All of your other inputs allow the operator to enable them and set levels as they so choose. When we look at the audio follow video set, what that is allowing us to do is move the fader to the location audio level that's desired to set that audio. So now, as sources are taken to air, they will move to their audio follow video position. The audio follow video is following the on-air status. Expression 1, or what would be CG1, is enabled and on air because, as we can see in our virtual panel, the keyer is currently on air. The source is CG1. As that key goes on and off air, it will enable the audio as well. Here in the example, key 2 has the clip store 1 channel. If that is enabled, so clip channel 1, which would be frame buffer 2, it also would be active in the mix. If the clip store was selected as a source in preset, so it's in my preview window, if the clip store is to be used in the preset bus and queue up our clip, and when that is taken on air using the cut or the auto trans button, the audio fader would move into its position for the default audio setting. And upon going back on camera, the audio would be taken off. So audio follow video, you have an enable if you want the channel enabled. If I want a channel always left open, it's also as simple as raising that channel, like my media store, and disabling audio follow video. And now media 1 is always open. And if I'm using this to play, say, an audio bed where the video channel is not going to air, this will make sure that as we cut sources, it's not being taken off air either. Every channel has a PFL or pre-fader listen. Upon selecting the pre-fader listen, that audio channel will be heard on our monitor output. So now we can listen to that output and adjust things accordingly. It's simple to clear it by removing it from PFL, or of course a PFL clear could be enabled as well. Solo will solo the individual channel out the program audio. Therefore, only audio that will be transmitted out of that program will now be the solo audio. The solo audio also does require a after fader listen. So here in the monitor output, this relies that the fader is also being driven with the solo. At the top, you'll also find your mute control, so being able to mute the audio while maintaining the fader level. So again, if I have a level that has been set, using the mute won't drop the fader, it will simply mute the channel. With all of your stereo audio inputs, you have the ability to set a balance. So it can be balanced to the left, it can be balanced to the right. Double-clicking in the middle or hitting default will set it back to center or to 0. All of your audio channels that have video mixes have these exact same parameters. The PC audio input has a balance control because it is a stereo audio as well. It has a mute control, and it has a PFL and a solo. There is no independent audio follow video as the PC is not linked to any video channel. Your AES input on the RAVE audio breakout unit has the exact same controls for balance, mute, PFL, and solo. And again, there are no audio follow video as there is no link to a specific video channel. When we move over to the analog audio inputs from the RAVE audio breakout, we gain a few more controls. Again, you have your PFL, you have your solo, you have your mute. However, your function command is changed because now it's no longer a stereo audio channel, but rather it's a mono channel. We're able to pan the audio either to the left of the mixer, to the right of the mixer, or maintaining it in the center, or in this case, a dual mono, so that it's equally in the left and the right channels. Each one of these analog audio inputs has a high quality preamp and also phantom power capability. So your next control is the ability to enable or disable the 48-volt phantom power that can be carried on that connector. The connector also accepts both XLR 3-pin and TRS quarter-inch jacks. The 48-volt is enabled, you'll notice that the icon will highlight red to simulate the fact that that it is now a hot port. There is also a high-quality 20 dB pad on every single input. You also have up to 60 dB of gain that can be applied via the gain controller as well. You have your audio meter inside so that as you're adjusting your gain, that audio can be viewed. If I'm using this as line inputs and it was coming from an external stereo device or a stereo microphone setup, then I could take analog 1, pan that to the left, take analog 2, pan that to the right, and now use these two in conjunction so that they're operating as a stereo pair. With analog 1 to the left, I would plug my left channel into analog 1. My right channel, I'd be plugging analog 2 in. With these 8 inputs, you can have any number of high-quality microphones directly plugged into the system, and it can even be used as a simulated stage box, as you can bring this over SDI in and out of the system. On the back of the audio breakout unit, there are also the Pali I/O as well as the GPIO, and we've covered how to configure those in separate tutorials. If there's any questions that you have regarding the audio mixer, or if there's other tutorials that you'd like to see, please don't hesitate to send them to us at switchers@rossvideo.com. Thanks for watching and have a great day.